Hi there, pre-algebra students. This is chapter 6.7, probability and odds. Earlier, we wrote ratios. Now we're going to use what we know about ratios to find probabilities. Let's say we're rolling a number cube, and we want to know how likely we are to roll a certain number. Each time you roll the number cube, there are 6 possible results. 1, 2, 3, 4, 5, and 6. Rolling a number cube is an example of an experiment. The possible results of an experiment are called the outcomes. When we roll the number cube, there are 6 possible outcomes: rolling a 1, a 2, a 3, a 4, a 5, or a 6. An event is an outcome or a collection of outcomes, such as rolling a 1 or rolling an odd number. Once you specify an event, the outcomes for that event are called favorable outcomes. The favorable outcomes for rolling an odd number would be rolling a 1, rolling a 3, or rolling a 5. The probability that an event occurs is a measure of the likelihood that the event will occur. There is an equation to help us solve for probability. It looks like this: P, event, is equal to the number of favorable outcomes over the number of possible outcomes. Let's use that equation to work through an example. Suppose we roll a number cube. What's the probability that we'll roll an even number? Rolls of 2, 4, or 6 are even, so there are 3 favorable outcomes. There are 6 possible outcomes, right? Because we could roll 1, 2, 3, 4, 5, or 6. So let's set up our equation. P of our event, which is getting an even number, equals the number of favorable outcomes, 3, over the number of possible outcomes, 6. So the chance of rolling an even number is 1 in 2. We don't say 1/2. You say the probability that you would roll an even number is 1 in 2. Okay? Using what we've just done, answer this. What is the probability of rolling a number greater than 1? The examples we've just worked through are examples of theoretical probability. Theoretical probability is based on knowing all of the equally likely outcomes of an experiment. A probability that's based on repeated trials of an experiment is called an experimental probability. For each trial in which the event occurs, we consider it a success. So experimental probability has a formula that looks like this: P times the event, or what we want to happen, equals the number of successes divided by the number of trials. Let's work an example where we'll find experimental probability. A miniature golf course offers a free game to golfers who can make a hole-in-one on the last hole. Last week, 44 out of 256 golfers made a hole-in-one on the last hole. Find the experimental probability that a golfer makes a hole-in-one. Okay, so we'll set up our equation. Probability of a hole-in-one is equal to the number of successes, 44, over the number of trials, 256. Then we simplify, which gives us 11 over 64. So the probability that a golfer makes a hole-in-one on the last hole is 11 out of 64, or about 0.17. Calculate this experimental probability on your own. You interviewed 45 randomly chosen students for the newspaper. Of the students you interviewed, 15 play sports. Find the experimental probability that the next randomly chosen student will play sports. The next things to consider when we're solving for probabilities is how to interpret our results. Probabilities can range from 0 to 1. The closer the probability of an event is to 1, the more likely it is that it will occur. Looking at this chart, you can see that the closer a probability is to 0, the less likely it is to occur. If a probability is equal to 1, it is certain that it will happen. Let's use a known probability to make a prediction. Today, you attempted 50 free throws, and you made 32 of them. Use experimental probability to predict how many free throws you'll make tomorrow if you attempt 75. Okay, so first, let's find the experimental probability based on today's results. You attempted 50 shots, and you made 32. So your experimental probability was 16 out of 25. Okay, now let's set up a proportion. If today you made 16 of 25, and tomorrow you're going to attempt 75 shots, we'll set up a proportion like this to solve for x, or the number of free throws you can predict you'll make tomorrow. Sorry, I didn't quite leave us enough room here, but I'm going to solve this algebraically by multiplying both sides by 75. So we get x equals 75 times 16 25ths, which equals 48. So you can predict, based on today's results, that you will make 48 out of your 75 free throws tomorrow. Let's take this one step further. On your own, please predict how many free throws you will make if you attempt 150 shots. Let's explore one last idea for Chapter 6.7, and that's finding odds. Suppose we randomly choose a number between 1 and 20. What are the odds in favor of choosing a prime number? And what are the odds against choosing a prime number? When all outcomes are equally likely, the ratio of the number of favorable outcomes to the number of unfavorable outcomes is called the odds in favor. So odds in favor is equal to favorable outcomes over unfavorable outcomes. The ratio of the number of unfavorable outcomes to the number of favorable outcomes is called the odds against an event. So if we go back to our question of choosing a random number between 1 and 20, what are the odds in favor of choosing a prime? Well, first we need to list our prime numbers so that we know what our possible favorable outcomes would be. All right, so what are our prime numbers between 1 and 20? 2, 3, 5, 7, 11, 13, 17, and 19. So how many prime numbers do we have? There are 8. So in this problem, we'll say we have 8 favorable outcomes. Therefore, we must have 12 unfavorable outcomes. So let's calculate our odds in favor. Remember, odds in favor is equal to the favorable outcomes over the unfavorable outcomes. So our odds in favor of choosing a prime number are 2 and 3. The odds against choosing a prime is our unfavorable outcome over our favorable outcome, which is 3 to 2. So our odds against choosing a prime number are 3 to 2. An interesting note here as we're talking about probability and odds, typically probabilities are expressed in a fractional form, A, B. Whereas odds tend to be expressed in the A to B form. Just something to note as you're working through this section of the chapter. All right, that wraps up our work on probability and odds. I'll see you tomorrow to do more practice.